Auzubillahiminash-shaytanir-rajim. Bismillahir-rahmanir-rahim. Assalamu alaikum warahmatullah. Welcome to this lecture number 21 and the third lecture of this week 7. So in this lecture we are going to solve some numerical problems related to sheet metal blanking, bending and the deep drawing operations. But before going to that, we are going to look into some brief information regarding the dies and the presses that are used in the sheet metal working operations, or in other words that I use in the press working operation. So the dies, they are mechanical, the conventional punch and die tooling, and when they are used in a combination for the high production stamping operation, high production sheet metal operation, so they are termed as the stamping dies. They are termed as a stamping dies. So these stamping dies, they can be made up of tool steels that are of type D, A, O and S. And what are these type? You will read, you will study about the tool steels in the next semester in the course of materials and metallurgy. Although the some details about these tool steels are given in table 6.5, so you can go into chapter number 6 and table number 5, you can check it out there. So this is the components of some conventional stamping die. So we have RAM, which is responsible to power the punch. We have the punch here and the punch holder here in this way, and they are guide pins. These vertical pillars, they are guide pins which guides the punch, which guides the path of the punch. Then we have a stripper, that is a kind of a plate that holds the stock. This is the sheet metal stock that we are feeding into the machine. This one, this blue one. And this stripper has a hole that is somewhat larger hole than what we are about to punch on the strip stock or the sheet metal stock that we have fed. This is a die here, the die opening. As you can see, there's some angular clearance in the die opening here. There's some angular clearance here. We have the die holder in the press base, which is made to absorb the shocks or the impacts that is produced while performing the press working operation, so that they are not transferred onto the floor of the factory. So we have to have a base for each press working machine. Then there's some bushing and there's a stop. What is the function of stop? If we are performing the blanking or the punching over a coil or a strip, the difference between the strip stock and the coil or strip is that they are continuous reel of the material we are feeding into the machine. So obviously we're continuously feeding the material into the machine. So that's why once we have entered enough material into the machine to perform the operation, the this stop stops the further feeding of the material until the punching is done. Then we keep on feeding the further material, then it stop it, and in this way this process continues for the whole reel of the material. So this is some conventional stamping die. So based on this, the stamping die can be of four types. The first one, simple die, as you can see the highlighted one. Simple die, we have the compound die, combination die and the progressive die. So what is simple die? As you have seen above, in this die, if you see, observe it briefly, only one operation is performed at a one station in a single stroke. Like you can see here, only one punching is done in one stroke. One stroke means the punch is coming down only once. So in a single stroke, the only punching is done, and in a single machine, the single bed. But if we go into the compound die, two operations are performed with at a single station with a single stroke. If you remember the video we have seen in the last lecture, in the last live session, where the blanking and punching was being performed simultaneously, so that was basically a compound die. So we have a single station, this whole is a station, and with a single stroke of punch, both blanking and punching is being done. So this is the compound die. Then there's another one that is known as the combination die, which is very less common. It performs two operations at two different stations. Like on the same stock material, the blanking and punching is being done at two different stations. if you have a large stock material. So it such that it is passing through two stations. So the blanking and punching is being performed with a single stroke at two different stations. Then we have the progressive die here, this one, that multiple operations are being performed with a single stroke. These all punch comes down with a single stroke, and the multiple operations are performed along the strip. So this is the progressive die and its product strip. We have the punching, square punch, semi-notch, parting. All these are type of the sheet metal working operations. So they all perform simultaneously with a single stroke on a same material. So these are the four types of the stamping dies. The other type of machines. Up till now we have seen that the machine that is used for the stamping or press working operation is called as a stamping die. First, stamping die based on its components and operation, it is of four types: simple die, compound die, combination die, and the progressive die. And we have already discussed the types. Now there's some other type of machines that are used for the press working operation. So that is known as the presses. So what is the difference between the stamping die and the presses is that we have always have a stationary bed in this case. Like in the case of the stamping die, we have the bed for the stock material was moving. The stock material is can be moved from one station to another station, but in the case of the presses, we have a stationary bed that all the operation will be performed on the same bed. Then it's powered by a ram that slides over the frame. So there's some basic differences between the stamping die. Like in the stamping die we have the guide pins and all that. In this case we have a ram here and the frame that restricts the movement. We have a flywheel and the drive for powering the punch. We have the bolster plate where we perform the punching operation. We have the bed here, right? So this is the component for the press working operation by using the presses, not the stamping die. This area of the these presses, they can be either mechanically powered as you have seen in this figure, or they can be hydraulically powered. So there are two different power method of powering the presses. So we are not going into much depth of this one. All I want you just to read the function of each of these, the explanation of each of these in this theory here, and the one we have already discussed, this one, stamping, progressive, compound. All you have to do is just to read the basics of this one. You don't have to go into the further types of the presses and the types. Now we will move on towards the numerical section. Deep drawing operation is performed in which the inside of a cylindrical cup has a diameter of 4.25 inches and a height of 2.65 inches, and the stock thickness is 3 by 16 inches, and the starting blank diameter is 7.7 inches. The punch and die radii, we have the 5 by 32, and we have the properties of the metal here. It's asked us to determine the drawing ratio, reduction ratio, drawing force, and the blank holding force. As we have discussed before, these drawing ratio and the reduction ratio basically are the factors to check out the feasibility of a particular drawing operation, whether that drawing operation is possible or not. So let's write down the data here. We have diameter of cup. We have the diameter of the cup here. So we have the diameter of cup, that is 4.25 inches, and we have the blank diameter that is 7.7 inches, and the height of 2.65 inches. The stock thickness, that is the T, equals to 3 by 16 inches, and the starting length number is already right. The punch and the die radii, the small r, we have 5 by 32 inches. So let's check out the drawing ratio here. That is drawing ratio. Drawing ratio would be equals to the die of the blank divided by the die of the cup. So we have the 7.7 divided by 4.25. So we have the value that is equals to 1.81. So this is, it means we are under the feasibility range of the drawing ratio. Now second one, we have to find out the reduction ratio, and the reduction ratio we have seen that is equals to the die of the blank minus die of the cup or the punch divided by the die of the blank here. So that is equals to 7.7 minus 4.25 divided by 7.7. So that should be equals to, that is equals to 0.448, or we can write it down as 44.8%. Now in the part C it says determine the drawing force. So as we know that the formula for the drawing force, so the part C is regarding the determining the drawing force. As you know that the drawing force is equals to F equals pi into the punch diameter into the stock thickness into the tensile strength of the material, and whole multiplied by dB by dP, that is a drawing ratio, minus 0.7. So just put in the values. We have pi into the dP, that's equals to 4.25, into the stock thickness, that is 3 by 16, and it equals 0.1875, into the tensile strength that's given here, 65,000 pounds per square inch. We have 65,000 here, into dV by dP, and we know dV by dP equals to 1.81, the 1.81 minus 0.7. So the drawing force should be equals to, so drawing force is equals to 180,900 pounds. Now the last part, that's the holding force, and in the holding force formula is equal to 0.015 into y, the yield strength, into the pi into dv square minus dp plus 2.2 times the stock thickness plus 2 radius die corner radii square. Into the die corner radii square. Right, this is the formula for the holding force. So we can put in the values here. We have 0.015 into the y, the value of the yield strength is 32,000 pounds per square inch, so we have 32,000 here, into pi into dv square, that is 7.7 square, minus 4.25 plus 2.22 into stock thickness into the stock thickness, that is 0.1875, 0.1875 plus 2 into the corner area, that is 5 by 32 inches. So that should be equal to 2 into 0.1565, 0.1565 whole square. Let's write it again. Whole square. So you can go and to calculate this one. So that should be equals to 52,000 pounds force. This is the holding force here. So this is the holding force. We have the drawing force and the feasible reduction ratio and the drawing ratio. Move on to the next numerical. So it says a bending operation is to be performed on 5 mm thick cold roll steel, and the part drawing is given in the figure as shown below. Determine the blank size diameter. So we have a stock technique with the width 35. We have this one 58, 46.5. We have some AV here, the band allowance. We have the internal radius of 8.5, the inside angle of 40 degrees, and the stock thickness of 5. So we can write it down here. The alpha prime would be equals to 40 degrees, the internal angle. Let's make it fine. Then the R is equals to 8.50 millimeters. Then we have the total angle of 180 degree, as you know that. So 180 degree minus as you know that we have the total angle of 180 degrees. So the alpha, the bend angle would be equals to 180 minus alpha prime. So it should be 140 degrees. So it has been bent 140 degrees. Then the bend allowance, that is equals to 2 pi into alpha by 360 into R plus kb of t. So we can have the what it says, determine the blank size that is required. So all we have to know that the size, the stock thickness, and the length of the blank, that is to be determined, the width and length of the blank. So we have the R here. We don't have the kb. We have the kba here as well. We have to determine the kba. And how we determine the kba? We determine kba by if the R is less than 2t, or if R is greater than 2t. So we can find out the R by t, that's equals to 8.5 divided by the stock thickness, that is 35. Stock thickness is 5, sorry. So we can have the value of 1.7, so which is less than 2. So which is less than 2. So we will have the kba value equals to 0.333, right? So we can just put in the values of kba here and find out the band allowance. So the band allowance would be equal to 2 pi into 140 by 360 into R, that is 8.5 plus 0.333 into the stock thickness, that is 5. So the AB would be equals to 24.84 millimeter. There is a band allowance. So the total dimensions for the blank dimension for the blank would be, we have the width equals to 35 millimeter as given in the figure. We have the length, that should be equals to 58, this one, plus this band allowance, plus bend allowance, that is 24.84 plus 46.5. 46.5, that's the length, so that would be equals to 129.34 millimeters, and we know that the stock thickness is 5 millimeter. So this is the dimension for the blank. Now move on to the last numerical for this lecture, that is a compound die will be used to blank punch and die a large washer. To blank and punch a large washer out of 6061 ST aluminum alloy sheet with a stock thickness of 3.5. The outside diameter of the washer is 5 mm and the inside diameter is 15 mm. Determine the punch and die size for the blanking operation and the punch and die size for the punching operation. So first of all, we look into the data that has been provided here. So if you go into your chapter or your course book, first of all you have to find out the AC from the table 20.1. Obviously in the examination it will be provided to you, so that the value for stainless steel or the 6061 aluminum alloy, that is equal to 0.060. That is the value for AC, and we know the clearance is equals to ACT. So we have the stock thickness of 3.5, so that would be equals to 0.060 into 3.5. So we have 0.210. That's the clearance. Now what it says, determine the punch and die size for the blanking operation and punch and die size for the punching operation. For the blanking operation, so the punch diameter would be equals to dB minus 2c. And how does dB minus 2c? You can go on to our lecture when you're discussing the punching and blanking at the beginning of the sheet metal working operations. So that's equal to dB minus 2c. So we have 50 minus 2 into the clearance, that is 0.210. So that's equal 49.58 millimeter. And for the die diameter, we have the same, that is 50 millimeter. Outside diameter of 50 millimeter. And for the punching operation, we have the punch diameter, that's equals to dB dp, you can say that's equals to 15 millimeter, because we need to punch a hole. The inside diameter is 15 millimeter and the diameter, that's equals to dh plus 2c, or you can say dp plus 2c. So we have 15 plus 2 into the stock thickness, 0.210. So that should be equals to 2 into 0.210 plus 15, 15.42 millimeter. That's the diameter of the dies. That's all for this sheet metal working operation, and it's the end of this chapter. Also, should you have any question, you may reach me at the Google Classroom. And sorry for some disturbance during this lecture because of the problem of my thought. So I hope you would bear with it. Even then, if you have any question, you may directly reach me at the Google Classroom. Assalamu alaikum.